Welcome to Advanced Java Programming at Portland State University. In this screencast, we'll learn about Apache Maven, which is a build tool for building Java applications. So what Apache Maven provides is a standard set of tools and conventions for building and deploying Java applications. One of the most exciting features about Maven is that it manages the integration of third-party libraries into a project and provides a very flexible plugin architecture that allows new tools and reports to easily be generated and integrated into a project's build system. So we'll be diving into lots of details about Apache Maven in the screencast. First, we'll take a step back and look at a little bit of history of building Java projects, and then we'll talk about all things Maven, how to build source code, how to test it, and how to report on it. Okay, so why do we need a build tool for Java? Well, as we saw in the very introductory lectures, there are command line utilities like javac and javadoc, and you've got the the JVM, the Java command. And yes, you could use those to build your projects, but as your application scales in size and as it does more and more things, you really need to automate the build process, especially if you're going to be sharing it with other people. Using a standard tool becomes a requirement. Now, for those of you who've been been around for a long time, there is the make utility that is sort of part of Unix. There are various flavors of it and everything, but it's been around for years. And the whole idea behind a makefile is that you have various artifacts and you establish dependencies among them. So going back to the C days, you have ultimately your executable that depends on object libraries that are built from C source code. And so you establish all these dependencies. And what the make tool does is it's smart enough to say, okay, well, if I haven't modified the source code for this particular object file since the last time I built it, I don't need to rebuild it. And believe it or not, I mean, this made a huge difference in the lives of developers because they have to recompile all of their code anytime they made a change. And makes really cool, but it doesn't fit very well with Java. The dependencies among Java files are a little bit more complex than they are with C. And make, while sort of there are various flavors of make, and while they all sort of do the same thing, is rarely platform independent. And let's face it, the syntax of those make files, it's very sort of 70 errors Unix. There are some lines need to begin with tabs, and it's just kind of wiki. It's just kind of weird. So we can do better. So in 2000, the Apache Foundation, which releases a lot of open source software, developed a tool called Ant to build their Java projects. And Ant was revelatory. It was really great. It provided all these building blocks for compiling, assembling, and testing a Java project. And Ant defined things called tasks that would then in turn invoke tools like javac, javadoc, all of that good stuff. This was all done with XML configuration that allows you to specify what the source files are and what the class paths should be, and it helped out a lot. However, they found that over time, each project had its own build procedure and its own particular flavor and usage of Ant. They had different directory layouts, they had different naming conventions, where various source files should go, things like that. And this meant that new developers had to, every time they transferred to a new project, they had to ramp up on the build system. Also, the open source Java code that was developed by the Apache Foundation leveraged lots of third-party libraries. So one project would be used, the jar file for one project would be used on another project, and there wasn't a consistent way of managing all of this. And so, for instance, when you had jar files that needed to be third-party jar files that were included in the project, they would sometimes check it into CVS, into their revision control, along next to the source code. And the revision control systems really aren't designed to handle binary files very well. And also, it was often difficult to determine which version of the library was used. Someone just said, "Oh, okay, I need JUnit. I'll just copy JUnit.jar." But what version of JUnit? So the developers didn't know which which APIs they could rely on. So so here again, Ant was really good, but after a couple of years, it became obvious that they needed something better. And so out of frustration with Ant came Apache Maven. So really, Maven was all about codifying patterns, maybe best or at least better practices that the people in the Apache world had seen. So, for instance, unit tests absolutely essential. They should just make it dirt easy to run unit tests. Also, generating reports and documentation about the project in a standard way. There are all of these Apache projects. They wanted a standard, a common set of tools for doing that. And then also, they wanted a shared or a standard scheme for versioning the software and deploying it off to a central location, so they can be shared more easily and shared using the same conventions and everything like that. So that was sort of the reasoning behind Maven, because what they wanted to do is provide a standard build environment that could be used by many projects. So every project has a notion of the artifact that it produces. Maybe it's a jar file, maybe it's a web application, something else from source code. So it has this common theme to it. Unit tests are a part of every project. Every project should have unit tests. It's integrated into the sort of the fundamentals of Maven. Maven will automatically download third-party libraries from central repositories and place them on the class path. So no more configuration of the class path, no more guessing where things need to go. Maven takes care of all of that for you. And also, because Maven is often used to develop projects that are deployed off to Maven repositories, it has support for publishing off to central repositories so that other people can use it. So how do you get started with Maven? Well, you can go to the Maven website at maven.apache.org. The documentation is good, kind of thick at times, but you can go and download it, install it on your machine, and that'll give you something called the Maven command line tool, MVN, Maven. To get started with Maven, you can create a project using an archetype. And actually, an archetype is something that we'll use a lot in this class. A lot of the sort of when you start a new phase of your project, you often start it from a Maven archetype. This basically is a template. An archetype is a template, if you will, for a project. So, for instance, this right here will the archetype :create, or actually it should be archetype :generate, I believe. Says, hey, just create a plain old vanilla Maven project with a group ID. Now, the group ID is associated with the artifact, so it's like, hey, what organization produced this? As we'll see, like in the assignments, the group IDs for this class or something like edu pdx cs410j, and then your login ID. My login ID is Whitlock. And then you give the artifact an ID, like project 1. And so this will generate a very, very simple project that can be built with Maven. And so running the archetype gives you 3 files, something called a pom.xml, and then a simple piece of source code in the source directory, and then a very simple unit test in the test directory. So this pom.xml file is really important. It's the project object model, or POM, file, and it's basically a configuration file, an XML configuration file. It specifies how the project should be built, or maybe more strictly speaking, how you configure Maven to build your project. We'll see some more examples later. So in general, this is the standard layout of a Maven project source code. All the files, all the not only just source code, but also resource files and et cetera, et cetera. Now note that you can configure this layout. If you don't want to put your source code in a directory called src, yes, you can change it. But one of the things that I've learned about working with Maven is that these conventions are there for a reason, and unless you have a really good justification for deviating, just follow the pattern. And Maven will take good care of you in the end. I've seen people that have tried to do other things for usually very legitimate reasons, and Maven doesn't work as well for them because it's not super flexible. It's not it's not as bare bones as Ant, and doesn't have sort of the inherent flexibility and configurability of some of the newer build tools like Gradle. Anyway, back to Maven. there is a base directory where that contains all of your project files, and there's your pom.xml, and then there is your source code. And now there are several kinds of source code. This isn't just Java code, really. This can be anything. So your Java code lives in source main Java, and that's sort of the base directory for your source code. And then you have your directory hierarchy that corresponds to your class name, and then any source code in that, directory hierarchy that corresponds to your package name, and then any classes underneath that. And you can also add a resources directory. Now resources are files, text files or whatever, that will appear on the class path and included in the jar file for your application. And so, as we've talked about in other, well, or actually maybe we will talk about in other lectures when we talk about the core API, these resource files can be read by your program, might contain configuration information, localizable messages, stuff like that. So you've got a branch in your source tree for your main application. You've also got a branch in your source tree for your test code, so test Java. And by the way, you can have test code in other languages. I don't think we'll be really talking about it in this course, but there is a language called Groovy that provides a very useful superset of the, well, is it really a superset? It provides a better syntax for doing Java things with a lot less boilerplate, a lot less overhead. It's really good for writing tests because they're nice, very simple little pieces of code. Anyway, you can have that here next to Java, but in this course we'll be doing just Java code. So here again you have your test hierarchy in parallel to your source code hierarchy for your main code hierarchy. And then also Maven has plugins that support building a website for your project. As you work with more open source Java projects, you'll see that a lot of them their websites follow the same template, and that template, that look and feel, comes free with Maven. And so you can have this little XML file that describes your site, and then you can have resources for that like CSS, images, all sorts of good things like that. So this is all of the source code in your for your Maven project. As you build your Maven project, and you'll see that we build it in various phases, the generated output get put in a directory called target. So for instance, the jar file for the project goes in the target directory. The reports and the other unit test output are put in the target directory, and then when you generate your website, that's also put in the target directory. The whole reason that you put all this in a single directory is that it makes it really easy to delete, and it makes it easy to exclude from revision control and things like that. If you have your artifacts all over the place, how do you know how to clean things up? How do you know if you want to just start over and recompile everything that you've deleted everything you need to delete? Maven says, well, let's just put it all in one place so we can delete it really easily. So what can you do with Maven? You've got all this configuration, you've got all this layout. Well, Maven defines several what are called build phases that perform, well, the kinds of things you'd want to do in building a Java project. So for instance, there's a compile phase, and you invoke that phase by saying Maven compile. And that will compile the source code in source main Java, or really just source main, and place its artifacts, the class files, off in the target directory someplace. So that's the compilation phase. It's building the main. Then there's the test phase, Maven test. Now note that these phases are dependent on the previous one. So when I say Maven test, it'll first go and invoke Maven compile. And Maven compile is smart enough to, if it determines that nothing needs to be built, it won't build anything. But after it runs Maven compile, Maven test will compile the test source code and then run the unit tests. The next phase is packaging, which here again will run the unit tests, which will run the compilation, the source compilation. And then what package does is it builds the artifact, most often a jar file or something, from all of the compiled code. Oh, and by the way, if when you run Maven package one of the unit tests fails, the Maven package build phase will fail, and it won't go any further. And this is what you want, right? So it's like if your code doesn't compile, why bother running the tests? If your tests don't all pass successfully, why bother building the jar? Another phase is the site phase, which will generate a website that contains project documentation and other information that's gleaned from the POM XML and various reports and plugins. There's also a clean phase, which deletes all the build artifacts. It's essentially an rm-rf of the target directory, but it can, but various plugins can configure themselves differently. Oh yeah, by the way, I'm using this word plugin. So there are these build phases, but there are also um, uh, these plugins that will do things like, well, like compile source code. So you'll see that one of the things that we configure is we configure the Java Java compiler plugin, Maven plugin, to compile using Java 7 language syntax. Similarly, there is a Maven plugin for generating Eclipse project files. So you can say Maven Eclipse that says execute the Eclipse goal of the Eclipse plugin, and that will generate your .project.class file for running with Eclipse. While Eclipse is fine, I'm personally a bigger fan of IntelliJ IDEA. And so to generate the project files for IntelliJ, you say Maven IDEA : IDEA. Okay, so when you build a very simple, when you use the archetype to build a very simple Maven application, Maven project, this is the pom.xml that you get. Yes, it's an XML file. Yeah, it's kind of hard to read. I'll try to point things out as best as I can. There's like the model version, which is like, what version of the POM am I using? It's always 4.0, so don't worry about that. You describe some things about the artifact that you're building. Again, that group ID, which is like, hey, here's the organization, here's the person that's putting it together. We use edupdx cs410j whitlock. That's what we had in the command line when we created the archetype. Artifact ID, this is the name of the artifact. Did I say heart attack? Artifact that's generated by this project. The packaging, what type of project, it produces a jar file. We'll see later later on in the course that you can create web applications and other various things with Maven. The version of your artifact, so 1.0 snapshot. 1.0 is pretty arbitrary, but the -snapshot means that it's not released, and snapshot dependencies and using snapshot artifacts is a little different than using regular ones. I don't think it's really going to matter so much for this course, but if you find yourself using Maven in the future, you might want to look it up. The name is just some display string. This is by default the same as the artifact ID, and then you can also specify a URL for your project. And these things are used by plugins that generate reports. And so they'll make pretty web pages, and somewhere on the web page will be a link to your URL. So also in your POM, when describing your project, you talk about the dependencies that it needs. What third-party libraries, or actually, yeah, a third party is really any other library other than the one you're building, does your project need to do its work? Out of the box, it needs JUnit, and for whatever reason, the default archetype still uses this kind of old version of JUnit 3.8.1. One of the first things that you'll want to do is change that to a more modern version 4.0, like we learned about in the JUnit screencast. So anyway, so what does this do? Okay, it configures again version 1.0-snapshot of project 1 released by the edupdx cs410j whitlock organization, and the project builds a jar file and its tests depend on version 3.8.1 of JUnit. Oh yeah, good point. It's just the tests, so you don't want your source code to use JUnit. You just want the main application to use JUnit. You just want the source code to do it. And so what you say is scope test to limit that dependency just to tests. Okay. So that POM that we just looked at was sort of what you get out of the box. You can also add a whole bunch more information to your POM to describe your project. So here again, there was that name. You can use a code name or something like that, like Guatemala. a description. Here again, it appears in reports and is available. So the POM is actually one of the things that's deployed along with your jar file. So anybody that uses your library will also download your POM, and so they can access this information in their reports if they'd like. A URL where you can learn more about the project, the inception year, when the project was started. Actually, if you're so inclined, you can go look at the POM file for all of the example code, and I've gone absolutely crazy with all sorts of stuff that you can go in there because I like pretty reports. I like having data. Yeah, so you can include information with the organization that it develops, who the people are that contribute to it, the license that's being distributed by, references to the bug tracking system, mailing lists you might have, your source code repository. So, for instance, if you're storing it in Git, you can go and reference that. If there's an automated build server, here again, they have this information in the XML file, and then there is a Maven plugin that will go create pretty reports out of it. Okay, all of that maybe not so important. What is important is how you manage dependencies in Maven. So I would say very often, almost always, your project will leverage some third-party library to do some part of its work. And the way that you specify what third-party libraries you want is by using this dependency tag inside your Maven POM. And for a dependency, you specify the group ID of the artifact's group ID, its artifact ID, what version of the artifact, and then scope. And here again, JUnit is scope test, but there are other kinds of scope. There is the compile scope, which is the default, which means that library, that dependency, and all of its dependencies, right? This is transit dependency. Like JUnit might use something else, and it'll bring in all of the stuff. It'll do all the analysis for you. And when you have the compile scope, that library is available to all build phases. So, like for instance, in your in the projects that you'll be working on that leverage my code, like for instance, student or your project one, my code is a third party, right? You didn't write my code; I wrote your code. If you go look in the POM .xml file for that, you'll see that it then has a dependency on one of my artifacts. As a matter of fact, let's just take a look at that real quick. We have the technology. Right. So here we have a dependency on the projects artifact from edupdx_cs410j. So that's the project.jar that contains all of the superclasses and interfaces that your projects are going to need. And the version here again is summer 2013. And so then I've got and the scope is not specified, so the scope is compile time. So at compile time and at runtime, you're going to need this this artifact. And then similarly, I have some tests, some project tests. So use a classifier. This is probably diving into details that you don't need. Anyway, here, just like with JUnit 4.5, is a test scoped dependency. So back to the slides. There's the compile or default scope, meaning that the library and all of its dependencies are available to all build phases. Runtime says, well, I don't need it for compilation, but I do need it when I run code, like when I execute test or when I run the project. So make sure it's there on the runtime class path, but not on the build time class path. Provided means that I needed a compile time, but at runtime someone else provides it. You most likely find this for libraries that are used maybe in a web container. We'll get details of this later in the course. But suffice it to say, sometimes there is a dependency that is just needed to compile time. At runtime, someone else will provide it for you. Tests, we've already seen a couple of examples of. You only need it for compiling and running tests. And then there's the system scope. And this is when you have a library that's not available in a Maven repository. So maybe I should step back and explain what a repository is. So there are these websites out there that store artifacts. that people can upload artifacts to, and again, you specify your group ID, you specify your artifact ID and the version, and Maven has conventions for storing all this stuff up on the web. And so another thing that you can configure in your pom.xml is here's what repositories I want you to look at. There are a couple of built-in repositories, the so-called Maven Central repositories, that'll go off and look for artifacts on. But oh, and I guess one more thing. I host a Maven repository on the PSU machines. Actually, it's hosting is too strong a word. There's something special about it. It's just HTTP. So it's just right. You hit a URL that follows a certain pattern, and poof, you get a Maven artifact. That's really all it means to be a Maven repository. So Maven repositories, they're awesome. But sometimes you want to use an artifact that isn't in a Maven repository. Maybe it's something that hasn't been published centrally yet. Maybe it's something that whose licensing prevents it from being put out in the open. Maybe you've got some commercial some commercial library that you've purchased, and so it's not available centrally. It's instead only available on your local machine, or maybe on some file system or whatever. Anyway, you can use the system scope to specify that. No, here again, I really jumped the gun on repositories. Just, I guess, to reiterate, Maven specifies a layout for repositories of deployed artifacts, what it should look like. So, for instance, JUnit, has the unfortunate property of having its group ID and artifact ID be the same. So, for instance, when Maven goes to look for the artifact, it'll look for JUnit/JUnit 3.81, the version, and an artifact named JUnit-381.jar. And it'll look for that in all the repositories that you've told it to look in. And oh yes, the repository also contains the artifact's POM, so that when you download JUnit, you can also go and download all of the libraries and artifacts that JUnit relies on. When you run Maven the first time, you're going to download a lot of code. You got a lot of jar files because you sort of do this transitive closure over all of the stuff that Maven needs to get its work done. It's going to feel like you're downloading the internet, but the nice thing is that you only need to do it once, and because it saves all the artifacts on your local machine. Actually, what's called a local Maven repository that we'll get to, I'm sure, in a second. So, as I said, by default, Maven will search for an artifact in a public repository. This is Maven Central, but you can also specify additional repositories in your POM. And so here is the one for the for my repository, the CS410J Maven repository, which may or may not. Oh, yep. No, that's something else. Oh, there it is. Okay, so here in the POM for your project class, there's a repository section where, yep, sure enough, you need to give it an ID and a name, and here's the URL that it's going to try to download my artifacts from. And again, when Maven downloads project dependencies, when they download all these artifacts, it plunks it in a repository on your local machine. So it's in your home directory .m2 for Maven 2 /repository. And so, sure enough, if you go look in your home directory repository, you'll see all sorts of good stuff. So like here's JUnit, all sorts of different versions there of JUnit that various 4.9, okay, that various projects need. It's not a small amount of files, but it's not too bad. And so the whole reason that it downloads them locally is that Maven will search for a project dependency in your local repository before going out to the interwebs to download them from remote repositories. Now, you can run Maven in offline mode, and it will not attempt to access remote repositories. And so this is the cliched use case of I'm working on the train and we're in a tunnel, or maybe I don't have an internet connection right now. Don't even try. Don't time out talking to people. So you can run with Maven-O or -- offline to prevent it from accessing remote repositories. Here's more detail on the various Maven build phases. We talked about a couple of these already, like compile and test. There are some other ones. There's a validate phase that goes through and looks at the pom.xml to make sure it's reasonable, and also downloads all the dependencies. That happens in the validate phase. Compile, like I said, test will go off and compile and run tests. Package builds the artifact. But there are some other ones that are downstream like that. There's an integration test phase, which does more than just the regular test phase. The regular test phase is about unit tests. It's about quick running, very targeted tests. Integration tests are about more holistic or system level tests. And they usually require that some system be brought up, like a web server, or a web container, or a database, or something like that, because you're doing integration testing. You're testing your entire application, usually end to end. There's a verify phase that can be configured to make sure that your artifact meets some quality criteria. So for instance, maybe on your project, you want to say, hey, listen, if there are any undocumented methods, I want the build to fail. Seems a little draconian to me, but it's an option that you have with Maven. Or maybe something like, okay, I want to make sure that there aren't any to-dos left in my code. Verify is probably not so interesting, but what is interesting is install. So what install does is it will copy the artifacts for that project to the local Maven repository so that other projects that you're working on your machine can use it. So install copies it, installs it locally. Deploy, on the other hand, will publish the artifact to a remote Maven repository, and you can configure in the POM what remote Maven repository you want that to be. So if you think about the life cycle of your project, you're sitting there compiling, and you get the unit tests running, and then you build the artifact, and you get your integration test running, you make sure everything's okay, you deploy it to your local repository, maybe you have a different project that depends on it. Finally, when everything's done, you want to go say deploy, and it'll publish it off to for the rest of the world to consume instead of just yourself. And here again, each build phase is dependent on the other, meaning that when you run Maven package, it'll run the test phase, run the compile phase, run the validate phase. So build phases execute goals in various plugins. So there's like a goal for compiling. There's a goal for running unit tests, for building a jar, things like that. And each one of the should be compiler. Anyway, and each one of these build goals is associated with a plugin. So a Maven plugin defines a bunch of goals that plugin supports. So something like so the Surefire plugin is what is responsible for running the running JUnit tests, for instance. So if you say Surefire test, that will run JUnit tests. It's conceivable that there might be other testing frameworks that you use that would have different plugins to support their invocation and reporting. A lot of what you end up doing in the POM is configuring these plugins. So, for instance, do I have an example of it? I do. So I will save that for later. Maven plugins are really the secret sauce of Maven, and really make it so powerful. I'm only going to go into a couple of plugins here in this screencast. But if you want to learn more, you can go to this URL and find out how Maven plugins work, and also see what they can do for you. The Maven compile phase will invoke the compile goal of the compiler plugin. Okay, you got all that? And for whatever reason, Maven, I think it's still true in Maven 3.0, is it uses an old version of the source. It assumes that it's 1.3 or maybe now it's 1.5. But we're on 7, right? This is like really old. So one of the first things that you need to do in your Maven project is tell the Maven compiler plugin, hey, don't compile for like old language level. Compile for the language level that I want. And so this is how you compile. You configure Maven. You tell the Maven compiler plugin to parse your source code using the Java 7 language features. Or sorry, Java. Well, this is Java 5. Perhaps in the perhaps in here. I guess I don't. I think I get in the parent POM instead. But anyway, we should explicitly configure those things. Oh, and note. And so when you configure your plugin, here again you give the group ID and the artifact ID of the plugin. And you should also specify what version of the plugin that you need. If you don't, Maven will go out and find the latest version of the plugin, which means that depending on when you've done your build, different builders, different people that are working with your project could use different versions of the plugins, and that's not necessarily a good thing because some people might be on older versions, some might be on newer versions. They might not support the same configuration. So a best practice is to always provide the version number for your plugins. Okay. Pardon me. Running Maven tests will perform the compile phase, so it'll compile your source code. It'll compile the test code into target test-classes, and then it'll run unit tests and put their report output into Surefire reports. Here again, the Surefire plugin is what is responsible for running unit tests. And if you want to just run the tests and not recompile them for whatever reason, you can just evoke the test goal of the Surefire plugin directly by saying Maven Surefire :test. Sometimes it's appropriate to just compile the tests but not run them. And so you can use the -d skip test option to Maven test, and it'll do that. And the Surefire plugin supports both JUnit and TestNG frameworks for Java unit testing. Okay, so we've compiled the source code, we've run the test. Now it's time to build the artifact, which for many of our projects will be a jar file. And so you can do that by running Maven package. Here again, it'll compile, it'll test, and it creates a artifact in the target directory called artifactid-version.jar, and it'll assemble them from the classes in target/classes. One of the things that we have in a number of your projects are something called executable jars. These are jar files that are configured to run a particular class's main method, and it makes it easy to invoke from the command line. But you need to tell the jar file which class is the main class, the one with the class with the main method that you want to invoke. And you do that by configuring the Maven jar plugin. And here's some example XML of how to do that. I think it's about time we actually saw something in action, so I'm going to go back to my example here. What I've done is I have created a Maven project from the archetype for the project 1 of the appointment book project. And so what I've got is a pom.xml and some source code. I want to build that source code, so I'll say Maven compile. It was happy. It said it was compiling one source code to the target classes directory, sorry, one source file to the target classes directory. I'm going to run the tests, Maven test. It ran the one test that was created by the archetype, and it was successful. And now I'm going to run Maven package. And that's going to build the jar file. So it's building the jar. Oh, that's the test jar. It also built the sources jar, all sorts of good stuff. Um, this is probably the jar that we find the most interesting. And now we can, oh, and that jar, let's look at the POM file. Um, here's the Maven jar plugin, and as you can see, we have a main class. That's our project one, and so that means that when we run the jar file, it's going to invoke our the main method of our project one class, which right now only prints out missing command line arguments. If you want more details about working with projects like this, I do have a screencast that goes through sort of the practical steps of running the archetype and then using IntelliJ to edit the class and build the project outside the scope of this screencast. But I highly recommend that you take advantage of it because it's essentially what you'll be doing in your projects too. Okay, so now that you've built your source code and you've run your unit tests and you've got your artifact, everything is hunky-dory, but there's more stuff that Maven can provide you. There are lots of tools for analyzing Java source code, generating reports for projects, and the better ones have Maven plugins for them. So, for instance, there is a Maven plugin that will generate JavaDoc for you. There's something called the JXR, which will generate sort of this cross-reference. Imagine if it's like an index at the back of a book for your project source code, and then there are other reports that will leverage this cross-reference for building other reports. You can get pretty HTML reports for your unit test results. And then there are a whole bunch of tools that will analyze your source code. Things like PMD that'll look for just like code that's bad programming patterns, things that are likely to cause bugs. There's a tool called FindBugs, which is pretty amazing. It has this whole repository of dangerous programming practices that they've built up over the years, and they've classified everything. And I'll show you an example in a little bit, but what this thing will do is look at your source code and then tell you, hey, these are potential sources of defects. You better take a look at them. The best thing, though, and the thing that that really attracts me to Maven is that it is so easy to work with these things. The report plugins are just there. You basically add 6 lines of XML to your POM, and poof! All of a sudden you've got all this documentation, all these reports for your project. It's just really, really easy. Oh my gosh, I'm not going to go into detail about all this stuff. You guys can read the documentation. A lot of this configuration is included in the POM file that's generated by the archetype for Project 1. And so, if you're really interested, you can dive in there. And of course, you can always ask me too. So you've got all these plugins that will generate reports for you, and then there's something called Maven Site that will take all those reports, because they generate HTML, among other things, but HTML, and put them all together in a nice website for your project. And so it looks at stuff in the POM and will put together pretty pages, relatively pretty pages, for describing who's on the project. All the project reports, like your API documentation, your test results, like code analysis, things like that. And then you can also specify your own documentation, READMEs, how-tos, wiki pages, essentially about your project. Maybe we'll put all this together into a website that can be deployed off to some web server someplace. And the project one. Has a number of plugins that are configured. So I'm going to run Maven Site. Now this will go here again. Rebuild the project, rerun the unit tests, and now it'll go and will generate a whole bunch of reports. It's generating JavaDoc right now, both for your source code and your test code. It'll run that find bugs utility. It'll generate various reports, all sorts of good stuff. And now I'm going to open target site. So it puts all of the output in a site directory. And if you open up the index.html file, here we go. Now, I don't have a tremendous amount of documentation in this bare bones project, and as a result, the website is a little bare bones. But it takes things like, the CS410J appointment book project from your pom.xml. So that's actually, I think that's the name of the project, yes. That is the name of the project here. And so, the stuff that generates these reports just looks at your POM. And so you have information about the team that that you can have. And here again, all of this comes from the like for instance, this developers section here of the pom.xml. We have members and contributors. Talks about all the plugins and which versions are used. Probably not so interesting there. But anyway, again, if you were using a particular tool to track issues, if you wanted to put a license associated with it, if you had mailing lists, all of this good stuff, dependencies, it generates all these reports, and it's also smart enough to do things like, oh look, when it got the dependency for the projects artifact, it went and found the POM for that, and now can link off to the URL for projects, which happens to be my website. So just things like that. And similarly, JUnit has its website and license information, all sorts of good stuff. So that's pretty cool. So it generates all that stuff from the POM, and then it has project reports that are generated from the analysis that you did on the project. So, for instance, it'll generate Java docs, which are pretty uninteresting right now because, well, we don't have anything. Well, you can't get the source code. That's neat. There's I've got the project configured to do some test coverage analysis. So, what code is executed by the unit tests? Find bugs, always interesting and informative. It's telling me, remember this only has like one simple little file, that it's okay. There is this dead class store of a class literal. This is something that's, I guess, apparently bad as far as find bugs goes, but I can go and easily find the source code here on line 11. Yep, that's right. I want to make sure that I refer to this class path this class just so that it can be loaded. You probably want to take this out. And find bugs then will bring this stuff to your attention. Anyway, all sorts of good stuff for you to peruse at your leisure. But here again, the thing that I think is so cool is that all of this was done with just a little bit of configuration. The Maven plugins take care of everything else: downloading the tool, running the tool, putting the tool's output in a place that other plugins can use it. It's I think it's really quite impressive. Okay, we'll go into a little bit more detail before we finish up. So again, running Maven install runs the package phase. We'll build the artifact and copy it into the local repository. And by copying the local repository, it means that projects on the same machine can use that artifact. You can there's another goal in the install plugin that will take some other artifact, not one generated by a Maven project, and stick it in the local repository. And here again, this is where, let's say you've got a commercial jar that's not available in a repository out on the internet. Instead, you need to put it in your local repository so you can build. This is how you can do it. So we'll install to the local repository. We'll deploy it off to a remote repository, a central repository someplace. It supports upload via FTP, SCP. I think there are more options now. And you can not only upload your artifacts, but you can also upload the site for the for your project. And in your POM, you can have an optional distribution management section, which will say, hey, here's a repository that I want to upload the artifact to. Here is the site that I want to load the artifact to. I've got examples here. And if you have, passwords or private keys or whatever, that can all be stored in a file called .m2/settings.xml. Just like you can install third-party libraries, you can also deploy third-party libraries. Here again, if you've got if you've got your own Maven repository, remote Maven repository, or you're running Apache or whatever, you can do that here. Probably not something you're going to do. I just want to let you know that it can be done. Okay, so as your project grows, you might need to have sub-projects or sub-modules of it, and Maven has a facility for doing this. You define what's called a parent POM that then refers to all of the child modules. You won't be using this in this course, but I use it in my example code because I have a number of different Maven projects with different artifacts that I keep organized using a parent POM and submodules. And note that there are some reports like JavaDoc and JXR that can be configured to roll up all the information from subprojects into one big report, which can be convenient, although I've found that Maven kind of struggles with this sometimes, so caveat emptor. And that's it. And I'll be honest, this is sort of a very cursory overview of Maven. I think the most important thing that you guys need to know is that it takes care of a lot of the downloading the artifacts, configuring class paths, all that stuff for you, so that you can focus in on writing your code, not building your code. Get it? Okay. So, in summary, Maven provides a standard framework for developing Java projects. It manages and downloads dependencies for you. It will take your code through the various build phases, like compiling it, running it, and then assembling the artifacts. And also, it can run a report, do analyses, publish artifacts, and a website all in one. And so this is really great. Not only does it build all your code, but you don't need to download and manage all those libraries and tools anymore. And so this saves you a lot of time. And here again, lets you focus on building your project, on writing your project, not building your project. Now, all that being said, there's a lot to learn here, and don't be surprised if this is a little overwhelming. Really, I think I just wanted to give you an idea of the breadth of functionality available to Maven. There's only honestly a handful of commands that you need to know, but I guess one of the things that I've learned is that as long as you play by Maven's rules, Maven will be very good to you. And so, invest the time in understanding Maven's conventions and how the plugins work and sort of what to expect, and it'll work fine for you. If you really need something flexible, there might be a better tool. But certainly for what you need in this class, Maven works very, very well. Okay, and that's it. It's kind of a long screencast. Hope you got a lot out of it. And I'll see you next time. Thanks for watching the Advanced Java Programming screencast from Portland State University.